This is our last mini lecture on power series solutions. This is the interval of convergence. Now we'll take y equals our sum from j equals 0 to infinity of x to the j at x equals 0.1, x equals 0.9, x equals 1.0, and so on. Now if you plug x equals 0.1, we'll get this here, equals this, which is approximately 1.11, and so on. Now x equals 0.9, we'll get this here, or this to 3 decimal places. X equals 1, which is just 1 plus 1 squared, 1 squared, 1 cubed, and so on, which is just diverges. It's not really any good for anything. You're just adding ones. Now an example here with the summation of j equals 1 to infinity of a of j, x1 minus alpha to the j. Now this converges at x equals x1 if the limit of j to n of x to the j tends to a finite limit, like if x is bound between -1 and 1 and converges to this value. So s of n equals this. Yeah, our basic power series form, probably the most basic there is. And we'll multiply this x, we'll multiply this by x, so x s of n equals this, provided that I does not equal 1. So s of n, we can get this as a recurrence relation. If -1, x is between -1 and 1, x to the n goes to 0 as n goes to infinity, and s of n goes to 1 over 1 minus x. So if x is greater than 1 and x is less than -1, the limit does not exist for any power series about x equals alpha. The radius of convergence is thus here, or in a what do we call it? In absolute value terms, is given here. So it diverges if x minus alpha is greater than r, or x minus alpha is less than minus r, which is this. Hence the interval of convergence, where alpha equals 0 and r equals 1, is this. So please do like and subscribe. There's lots more to come.